and welcome back to this one. Today we are going to be looking at finding the highest value in the list, and we're going to be doing it in a different way as against the last video. But this time around, we call our first conditional, where we do what? We first, go about checking if the list is actually a list with values, and then say, oh, chill, and uh chill with this, have this error returned to us. Basically, this array cannot be empty because we can't transverse through that. Now we call our base case where we say that the length of the array minus 1 is when the index is equals to it, we should return that array at that index. Basically, this is just a typical way or classic way of saying when we get to the last element of this array, right, return that the array at that index, because length minus 1 is just basically the last index of the array, right? And now we say recursive case, right? The recursive case where we call the highest of the rest, find highest array with index plus 1. Now we are thinking of a recursive call when we say highest of the rest. So what does that mean? We are saying if we are at 1, return me the highest of the rest of the list. That's what it's saying there, right? And here it will be 44. And when we get that back, compare it with my value array at that index of, say, 0 now, which is 1, and we find the highest right there. So basically that's what it's trying to do with this line. And obviously this line then explains itself. We're finding the max between the highest of the rest and the highest of this. Say this was 55. The highest of the rest will be 44. This will be 55. They will compare. 55 wins, and that's returned as the max. So that's it. We see our tree where it holds values at different, it holds the indexes as we go down the tree, and this shows us that when we return 2 at the bottom, 44 versus 2 gets the max weekly. When we return 44, 44 continues to transverse and win this guys in the max game, and at the end 44 is returned as the highest value. So let's see how this transverses over our debugger 2. Did I miss something? Sorry. Now, let's get into it. Okay, so we see that index is 0 at this point. So index remains 0. Index is not satisfied. We get into it and we return the highest of the rest, which is 2. So index is at 3 right now, right? We skipped to index of 3, which is at 44. Highest at that point is 2. So basically it's this guy. So it skipped to the one before this, before 2, and then it returns it, and we're checking. What we are checking now is we are going to now in the next line. Oh, okay, that was it, checking the 2 of them. Highest is 2, and then the array with this thing. So meaning that our highest at this point now will be 44. Do you get? Because we are transferring back. This is index of 2 now, where we will see that we are comparing 44. We are going to be comparing 44 with 33, right? And we're going to be looking at on who wins that game. I could have probably put a print of the index of that array so that we also see the index of that array, but when we see that index is 2, obviously this is 0, 1, 2, so 33 is who is comparing itself as against here. It's showing us the highest, it's showing us this thing, but it's not showing us obviously array of index of 3, right? So let's go. When it compares again, it wins that battle, and then when it comes to index of 1, it is going to be comparing with 2, and we could see that 44 keeps winning, and the index of 0 as well. It also continues to win that guy, and then at the end of the day win the golden highest money. But yeah, that's basically it for the highest. It takes a different approach as against what we did yesterday. I think this is more sleek, but yeah, I think I appreciate it better. See you on the next one. I'll fill that in. Choose.